So now we are starting the second module is the AI history and machine learning. So just to get started, we're going to use this fancy Boston Dynamics the robot image, and also IBM Watson, Echo, Alexa, and all those intelligent bots and DeepMind like this AlphaGo and AlphaZero, which beats the really almost really difficult game called Go. So we actually, I think I really don't need to tell you AI is changing the world. AI is important. So, but to echo what I covered in the first module a little bit is, so it's exciting, but it's also scary at the same time. So the machine learning kind of centered artificial intelligence techniques now changing almost every corner of our human society and almost every corner in this planet. It changing has profound economic, cultural, social, health. It's creating endless disruptions. It lowered the cost, but at the same time, it also affecting each one of us. It may replace the labor forces for more than 50%, make them totally automated, maybe just in a pretty short time. And also this type of intelligence robots, are we always have control? I mean, it's hard to say that, right? So it's a good time to really think about this and also be very mindful of what you're going to produce. So the reason why I really want to emphasize this is, so even though you're just undergrad, honestly, I just see so many good undergrads graduated from UVA, also from my group, and I feel the ability they have to creating good tools, it just so they're just so good. I mean, every one of you, I mean, think about, even though you may not be aware, but in fact, you're very, very powerful. So when you have this powerful knowledge in your head, this powerful ability in yourself, and have this good judgment, it's extremely important. It's actually not, in fact, it's not for you. It's more for the bigger, your neighbors, your society, your people, other people on this planet. So be always very mindful of how your tools are used, are being used, and will be used. So be very, very careful. So that's the thing it's more like a sharing theme across all the different sessions of this class. All right, so let's define what is artificial intelligence. So used to, like, people just saying the artificial intelligence is the study of computer system that attempt to model and apply the intelligence of humankind. But honestly, I think this is a very murky definition. And first of all, what defines intelligence? And human intelligent? And then what's the intelligence level of monkeys and dogs, even the plants, right? So it's this artificial intelligence definition. If we only use the humankind as a reference, it's a little self-centered, to be honest. That's what I always feel about the definition. So I want you, when you think about it, think a little bit broader, and think about this intelligence is more like a spectrum of different kinds of intelligence. And then let's see, how can we build more intelligent computer and machines? So first, let's decompose, let's use human as a reference point. The first ability is to perceive, right? We need to be able to see the world, hear the world, right? So that's exactly, in fact, what the current AI has been developed to be really good at, is the object recognition, speech recognition, and then later is this, like recently is this semantics, understand language semantic. They're all mostly in the perceived level, and then later, recently, they reached the understanding level. So we want the computer to be able to do automated machine translation, text semantic understanding, and then to be even more, one more step is to be able to interact. So that's the game playing with the Go Play or the OpenAI have a lot of those AI agents to be able to better than human playing games in those virtual world. And then there's also really big important function is to able to think, reason, and learn. So that's about, can we make train AI or machine learning based AI agent to be able to programming and to be able to write a deep learning architecture. So, and then even further, can we train a machine learning or computer software that be able to make analogy, to imagine, and then that's the recent really breakthrough, something called generative adversary like networks. So can we imitate a specific author's novel writing? Can we imitate a specific artist music generation or a singing style? So that's just, again, pushing to even a more personalized level, right? To be able to style imitation. So these are all can be seen as part of human intelligence, and there are sub-algorithm that is able to achieve some level of each of the functions, each of the components of the intelligence. So behind all those are method. There's this page is more like we can think about some more trajectory history of the AI, those methods centered in the AI systems. The very classic AI, like knowledge-based systems, they are dominated by rule-based. They're mostly dominated by the rule-based system. Then that's about like I think it's 1970s. So I will have a page talk about the timelines of this different method, like from 1950s when machine learning is more like a formally created as a subtopic, and then until now. And so the rule-based system, and then there are also neural network-based systems. So if we see from a method angle, we can have just put them into a one-dimensional line. Is from rule-based to classic machine learning-based, and then to representation-based, and then to deep learning that is now. But history doesn't happen in this way. It's not just 1950s, we have rule-based, and we have classic machine learning, we have representation learning, then we have deep learning. And in fact, I mean, the current state-of-art deep learning method being used a lot was, especially a few really important algorithm was invented even before the classic machine learning, even before this rule-based. I think there's one of them is invented before the rule-based system. So this invention doesn't happen in a linear way on our timeline, but we can think about our method in a more like a sequential, so you can think about this is more from a functional perspective. They can be organized in a one-dimensional line. All right, so let's now look at a different coordinate, which is a time coordinate. So in the early history, and then actually in 1950s, this Alan Turing wrote a landmark paper called named as Computer Machinery and Intelligence. That's almost, you can think about it's the first defined moment of AI. So can machine think? And then later, in 1956, there's a workshop at Dartmouth sponsored by a very famous mathematician. And then this workshop formally defined the definition of AI, artificial intelligence. And the artificial intelligence is actually, we can think about it as a superset of machine learning. And in 1950s, there's actual neural networks. In 1960, there's a lot of neural networks, which is the like ancestors of current deep learning. They were very dominating in the 1960s. And then they kind of died. And then the first most important, so in those 1960 versions, they're not that practical. The truly first, their practical AI systems were all like rule-based. And that's the thing actually still used a lot in the state of the art. A lot of those like medical decision systems, even I think there's policy making. Those are invented mostly in 70s and 80s. So, and the fundamental idea there is to give this AI system a lot of knowledge to start. Yeah, so in the form of mostly in the logic form. And then so what's dominating now, it's something called neural networks. And but the neural networks, it's not just invented now. They were very dominated from the beginning of AI, from 1952 to 1969. And then they were replaced by the expert systems, then 70s, 80s, then so like you can see 50s and 60s, it's the NN, then 70s is expert, and then go to the 90s, 70s and 80s, and then go to the 90s, we have this NN again. Then in the early 2000s, we have the classic machine learning is mostly SVM, that type of classic machine learning. And then starting from 2010, and it's something, it's just renaming called deep neural networks coming back, and then started to have this really revolution of our era. So, but the very important idea called convolutional neural net and also recurrent neural nets, and both of these two fundamental modules that's really important now were invented in 1998, around 1998. And so the recent MIT Tech Review, I mean, almost all has a lot of like highlighted deep learning breakthroughs. So in 2013, it was like first have this deep learning terminologies got kind of popular, so popular. And then later it was magnified by deep reinforcement modeling from the Google DeepMind in that revolutionary winning like Go gamer called AlphaGo. And then later got another breakthrough in 2018 is this technology called generative adversary networks. Okay, so what starts this new deep learning era? So in fact, it's the ImageNet challenge in 2012. So before this, the convolution-based method dominating this task called object recognition, and it was all the previous. It's a very big competition with about 2 million images, and before. It's all the winners are handcrafted computer vision pipelines and using the classic machine learning as the predictor. And then in 2010, there's this network called AlexNet, and it kind of increased the performance of upon the previous best performed pipelines, like more than 10%. So this is the true breakthrough because it just dramatically improve the prediction performance. Never happened before, and very largely. So this is a true milestone, and you can tell from the performance there. So these before that 2010, it's like 0.26, and then after the this deep learning AlexNet, it improved the error rate from 26 to 16. And then people just keep pushing the performance to be really, really good until 2016. And it's even better, actually, in fact, to 0.03. It's even better than the human performance. So this truly opens the era of deep learning, like this industrial revolution. And that's opens the door of many, many important machine learning new algorithm and new application. So this is a recurring theme in machine learning is there's some benchmark competition, which is really difficult. And then people use whatever current, and then they are all perform very similar. And there's this kind of disruptive method coming in, and then it just has this dominating better performance. And then it's, and those moments are the defining moments of the most AI history. Yeah. All right. So we know deep learning is changing the world, and there are all those bots, especially in medicine domain. There's all this imaging-based applications. It truly pushes into the true use, and text mining, and then drones, speech recognition. So let's ask the question. So like I said, right? So we have this deep learning method. In fact, in 1960s, 50s to 60s, it was invented, then coming back in the 90s. Why it's now? I mean, there are a few reasons, and this is more like three most prominent reasons. First, because we have plenty of data. The second is we have this advanced computer architectures. And the third is there's really good, powerful deep learning platforms, libraries are supported by those IT giants. And then first reason is plenty of data. So this actually, we don't even need to explain this. So they're just, because the internet, because the digital platform, because everything goes into digital, I mean, there are just trillions of language data, billions of imaging data, video data, audio data. There's also, with the current IoT, sensing and smart everything, right? Especially smartphones. We got all those human user tracking data, sensing data, and those really, it's just providing this potential ocean of data, and it makes the data driven as it's not just part of the statistics or not part of the computer science, it's even created this new science called data science, right? So just in our, what we may be going to use, I mean, your projects, there's also huge amount of genomic data because the next generation sequencing technologies, and also there's a huge amount of medical imaging data. And the second reason is there's this advanced computer architecture that really fits deep neural network really, really well. And so we used to be dominated by CPU architecture. Now we have the GPU. And we're going to talk about this later when we talk about the first, like why GPU helps. So this will be covered later. All right, so the third reason is this really good machine learning methods. So now we truly finally touch the machine learning. So what is machine learning? So we can think about it's really an inductive reasoning machine, inductive reasoning software. It can generalize from the observed past data to the future unseen data. So this is that from this logic perspective. It just, I'm trying to, if I see in the past, there's this XY pair. When there's a future X prime that's very similar to X, I can generalize and then to know what should be the Y, because I have some beliefs, some understandings of X to Y. So this will be more clear in the next few slides. So to summarize, we want to be able to build computer systems that can learn and adapt from the experience. And machine learning, kind of a little bit different from statistics, is and it provides this very well engineered software architectures and to build upon. And in the beginning of machine learning, what we care is to provide prediction accuracies. But recently, because we are shifting more and more from not just machine learning, but machine learning software, and there are many properties that we actually, as from computer science principle, we try to add a lot more on this generating machine learning models. It's not just accuracy, and I'm going to talk about that later. We also care about robustness, interpretability, sensitivity, like testability. Those are all just from a the software perspective. So, okay, so just to categorize how this machine learning differs from the traditional programming. And we can think about traditional programming is the software programmer. They generate the algorithm, and then they code the algorithm, and then this algorithm and data pass to computer, it generates output. And then we can think about machine learning, it's more like, okay, so no one is generating algorithm. So what we are giving to the computer is just data and also the desired output. And this machine learning, there's a phase of machine learning is, okay, I just give this computer a data and the interested output, it will generate a algorithm. So that's the easiest way to kind of reference to the traditional programming. So how different is machine learning versus the traditional programming if you are more a CS perspective? So machine learning is using data and also this properties of data and this kind of output of data to generate algorithm. We are generating algorithm. In the machine learning context, this algorithm is the model. All right, so to look at it is a little bigger scopes. Machine learning has a lot of overlaps. I mean, you can overlap with applied mathematics, applied statistics, information theory. It also has a lot of overlap with social science because we care about those. We want to have social good impacts, right? And it's also tools, right? I mean, machine learning are generating tools on top of computer systems. And like just to echo what I just said, so in the beginning, people only care about machine learning in terms of prediction. And then it starts from this prediction circle. Now and more, people also care about computational properties. Is it fast? Is it efficient? Is it scalable? So that's more the computational angle. And then more, I mean, from this security or social perspective, is it robust? Is it trustworthy? Can I trust that computer algorithm to make a decision? So the final decision just has to, should locate at the intersection of the three. So let's kind of project the future. You know, this type of machine learning method, it just becomes so powerful. And also the digital data platform generating this comparable data. I mean, it's from everywhere, right? It's from sensing, from sequencing, from genomics, from almost every part of this society. And what is the future? Is future just about generating data, then process data? It's future, every research is about data processing or data understanding. Is future about, when we have more and more data, will this influence our society more? Are we always the controller of our data? Are we always controller of our algorithm? Will this algorithm actually changes the human itself, ourselves, right? Think about all the kids now like almost grown up with watching YouTube or whatever those videos, and how those influence their cognitive understanding, cognitive ability, how our human is co-evolved with this computer. It's really a question that is not answered yet. So just to borrow Bill Gates, this vision sentences he said, we always overestimate change that will occur in the next 2 years and underestimate the change that will occur in the next 10 years. So why do I say this is I want to actually more like introduce how my vision or my philosophy of design this class. So in summary, I hope I can make you an excellent graduate from this class. So you graduate really well after you finish this class. But what do you even mean? How to define excellence, right? So this is my general 2 views about excellence. So we should have a good breadth of the fundamentals. And at the same time, we should have strength, have those really highlight points in a particular targeted topics. And those will help you stand out. So this is my general philosophy about the teaching. And also my definition of how this class, an excellent student graduated from this class. All right, so, and then this really involves 2 steps, right? There's this exploration, which make like a breadth part. Exploitation, it's about the focus. So one is broader, and the other is focus. So the homework, it's assignment, it's more like a broader coverage of general knowledge, and the projects is more like a focus endeavor. So I hopefully this explains why I designed the class like this way. And the quizzes itself is the minimal basic knowledge exploration. And so just a little bit off topic, like echo my point about good and bad. So I want to introduce you, if you have extra time, feel free to read these 2 big books, which changes my view a lot. So first book is called Master Algorithm. And this is more like a historical revision about what are the philosophical ideas behind different tribes in machine learning. So you actually can categorize the machine learning researchers or the different style of machine learning research using this 5 style. So there's something called using symbol, it's more like a logic-based, then connectionist. They're mostly, so rule-based system mostly using this philosophy, and deep learning mostly relies on the second called connectionist. And evolution is more like the simulation. The evolution has a lot of in the game theory and in search, discrete search. And then the Bayesian, it's more, there's a lot of roots from the Bayesian, from Bayesian statistics. And there's also something called an analogizer. So a lot of this recommender, this like Amazon type of recommendation, it's actually almost completely based on this philosophy called making analogy. So this is one type of decomposition of machine learning. And so the second book I really highly recommend is something called Homo Deus. And I guess maybe some of you actually already know this book. So this book, like Homo Deus, explores the project dreams and nightmares that will shape the 21st century, from overcoming death to creating artificial life. It asks the fundamental question, where do we go from here? And how will we protect this very fragile world from our own destructive powers? So this is the next generation of evolution. And especially after pandemic, I feel this is even an urgent question to be answered. And it will change how the society really works, how the technology changes society a lot. I mean, pandemic itself, it's really a very strong technology pushing factor. And the question really needs to be thought through well. All right, so I'm finishing my second module.